So a lot of people are very pessimistic about the prospect of making very small black holes in particle accelerators, and they're worried about the extent to which these objects could be contained. They're worried about the extent to which these objects may begin to accrete new material and grow larger. Um, People were also very worried about the possibility of a small black hole emerging in the Large Hadron Collider in Switzerland when it was first turned on, I think in 2008, was it not? Yeah, this possibility of creating a very small black hole was put out there in the media surrounding, or the media when the LHC was turned on for the first time. And people got quite worried about that then. What I believe about the Higgs detection event is somewhat off the beaten track, somewhat obscure, and it's basically that a naked singularity was created by the collision of two protons in the Large Hadron Collider, and that the evaporation of the singularity, which would have taken place almost instantaneously, released two gamma ray photons as the decay products of these protons colliding with one another. So people want to build larger particle accelerators for all sorts of reasons, and this is something that Sabine Hossenfelder, I think, is probably against. No, or I think she's spoken out in somewhat disparaging terms about this prospect, about this notion of building ever larger particle accelerators. However, I quite now like the notion of building larger particle accelerators. And I think the reason why I like it is because I happen to believe that there's probably a very large chance, or a very good chance, that we could in fact contain small black holes. And if we can do that, well, then that raises huge possibilities and huge avenues for where technology like that could lead. You know, could we be on the verge of, say, building a Kugelblitz engine, one of these engines that relies upon a black hole stored or contained as, in the first instance, I suppose, the energy storage device or the fuel source for a spacecraft, and you know, channeling all these gamma ray photons emitted by it and its evaporation out the back of the spacecraft to generate thrust. I actually really like the idea of doing that. You know, the more I consider the possibilities inherent in being able to manipulate black holes, or being able to create black holes, since a very small black hole would be very, very short-lived, it probably wouldn't begin accreting matter. But if we want to really begin studying and understanding black holes, as you know, I think physicists think that we do, surely the best means of going about that, therefore, is by trying to create some little ones, some small black holes, seeing how they behave, seeing how they evaporate away, and so on. Like, this is real science fiction stuff, is it not? Like doing experiments really with black holes. That's quite something, is it not? Like, as an idea. And I think we may have been doing it already with the LHC. So why not in that sort of adventurous, scientific, need to know via taking some possibly very manageable risks? In that adventurous spirit, why don't we try and do things like create black holes, little black holes, or try to create Kugelblitz engines? I think we should. I think it'd be a really good thing to do that. And yeah, I think there's some manageable risk, sure, with doing that. They can be, you know, dangerous objects after a point, I think. But yeah, we just need to figure out how long it takes them to evaporate away. It could mean that you know, a flea egg mass black hole, a Planck mass black hole, it might evaporate away after, I guess, a Planck second, or something like that. Planck time, possibly. Who knows? I don't know. But if we can harness that, we definitely should be. I think we should be. Yes, it'd be good. Science, yes, and less pessimism, hopefully.